Welcome. Today we're going to solve a quantization problem. From our given problem statement, we are provided a sequence of real numbers that have been obtained from sampling an audio signal. We need to quantize this sequence by dividing it up on the interval from -4 to 4 into 32 uniformly distributed levels. Then we can write down the quantized sequence and determine the maximum number of bits we need to transmit the sequence. So the first thing to do is define how we can fit 32 levels over this interval. And since we know the quantization is uniformly distributed, we can use the equation delta equals the highest value in our interval minus the lowest all over total number of levels to find the step size of each of our levels. So, plugging in for these values, we have 4 minus -4 all over 32. And simplifying that gives us 0.25 for our step size in each level. Using this, we can plot the relationship between the given values and our quantization levels. If we start plotting at the lowest point in our interval and the lowest quantization level, and we move to the right until we hit the calculated step size. When we do, we jump up to the next quantization level. We continue plotting until we hit the next quantization step size and go to the next level. And you just continue on and so forth. If you do this for the whole interval, you will get a staircase relationship between the interval and the quantization levels, as shown here. Now, taking the original sample values and finding their quantization level is really easy from this graph. So I will do a few of them. So if we have 1.8 as our input, so we found 1.8, which is about right there, and we go up. Make sure I get the right place in it. It's about right in here. So it maps to 23. So the 23rd quantization level is what 1.8 is. Now if we take 2.2, which is about right here, it's not really half, and you go up, you'll see it maps to around 24. So you get 2.2 maps to a 24th. Now 3.2 is right in there. It maps to the 28th quantization level. And then negative 1.2, right here, maps to the 11th quantization level. And finally, 0.1, right around here, maps to the 16th quantization level. So doing that for all values, you can find the quantized sequence. The quantized sequence of the original values. Here is the quantile sequence generated from the quantization of the original values shown here. Now, the last question in the problem was to find the maximum number of bits required to transmit this sequence. So we know that there were 32 quantization levels. So that means we need log base 2 bits required to represent that. And that comes out to 5 bits per sample. We also know that there are 32 samples that were provided. So, if we take 5 bits per sample, and we multiply that with 32 samples, we get 160 bits needed to send this quantization sequence.